There we go. Sorry about that. I think we're great. Good to continue.
All right, let's have a look. So back to the beginning. We have values. Let's say, let's remove this for a moment. We have a type called A, which is a constructor called A. And we can show it. Now, if I have a value of type A, the value might be the constructor A. I can print it and I see a thing. So a value is this thing you see on the right side of the equals. The type is what you see on the right side of the two colons. And we can, very broadly speaking, give values names. That's how the whole thing works. Okay? Now, let's say that built into the language, we have this thing called print, which can print anything we can show. By show, I mean turn into a string. Now, I can't define it, but let's say this exists. Okay?
Mhm.
Now, if I say print 5, what I've done here is I've put the 5 as the argument, the results. So the type of print 5 is of type IO of unit, so an IO action. This is the type. This is the value. And if I give that the name main, then Haskell knows how to do that, essentially.
Mm-hmm.
So far, so good?
Yep. Yep.
Now, forget about any syntax you may know for a moment, like any extra syntax you may know for a moment. Let's say you have to do more than one thing, like print something and then print something else, right? That means you need some sort of function, let's call it and then, which takes an IO action and another IO action and does them one after the other.
Okay.
Right? Do this first, do this next. So we are creating a new IO action which consists of doing the first one first and the second one second. Okay?
Yep.
Now, this thing exists. It's called, it doesn't have a name, I think, but that's what it's called. So you can say print 5, then print 6. Okay? And in general, it's
Yep.
actually a bit more general because you can say an IO action that produces something, ignore that result, an IO action that does something else, and return that result. But that's something we don't need to worry about for now. Okay, so we have a way to do one thing after the other. Okay?
Mhm.
Now, let's have a look at this IO action thing. This type IO, if I see IO of int, the way you read this is an IO action that might change the world and produce an int in the end. Okay?
Mm-hmm.
So read int of IO int might be a function that can read a piece of text from your terminal, figure out if it's an int, and then return that int. Okay?
Yep.
So that's what this value means, IO of int. Now, if there's a function called getLine, which is of IO string. If I get a line, so let's say what I would like to do is get a line and then print it again. There's another function called putStringLine.
Mm-hmm.
Right, so let's say I want to do getLine and then print that line. Right, so first I get a line and then I print it. That's what I want to do. This will not just work with this operator. Why? Because I'm not just performing one action before the other. I want to use the result of one action in the second action.
Mm-hmm.
You see why that's not possible with this function?
Well, I guess because the two with the function and we've said that they're going to be separate, basically, right? They're not connected in any way.
Exactly. So we want to figure out a way to get the result out of this action and then use it in the next action. Okay, so we need
Right.
a
So we have to
function
store
that
it.
looks like a what? Sorry.
We need to store the result
No, we don't
of
need to store
getLine.
anything. There's no such thing. We can give it a name. That's true. So what we need is if a function and then using, which takes this first get line, and then a function that uses this thing, should it exist eventually, and turn it into an IO action. So we want the function that lets you produce a value in IO and then use it to do more IO. And if we can put those together, we can compose them into an IO action. So this IO action that we're producing here consists of first executing this action to get this string, and then using the string to do another action. Does that make sense? This is what we would need. Do you agree?
I think I have a hard time seeing some of the difference there, like how. Um, yeah, I'm
So
seeing.
that's the
I'm
file.
having a hard time seeing some of the difference there because like the type in your second and then using your function of string IO. I'm not sure how we go. Yeah, I get a little lost there on how those two are actually different. But that's probably needing to understand some internals of the compiler.
How? No, no, no. How which two are different?
And then using.
Okay. So what and then does is
Or I guess what
do.
what I'm confused on is how the changing those the type annotations is telling the compiler that you want to string those
Oh, it
together,
doesn't.
that you want the
It
two.
doesn't. It doesn't. I'm just saying we need a function with this type in order to put them together. I haven't told you that it exists yet.
Okay.
I'm asking you to agree with me that this is indeed what we need.
Well, I can trust you on that one.
But you understand it.
I don't want to say that I understand it, but I understand where you're going.
Well, that's the issue. That's exactly the problem. I need you to understand that this is indeed what we need, because what I'm asserting is that there's no other way we could possibly compose programs stringing along results than to have a function like this.
Yeah, and is this like a getting into the currying that we're needing to? Okay.
This has nothing to do with currying. In fact, you could say do it this way, like you're used to in other languages. That means the same thing.
Mm,
Modulo,
okay.
like multiple PhDs worth of differences.
Okay.
Okay, so what we need is a way to take one action, and then use the result of that action to produce another action.
Yeah.
Is that right? Does that make sense?
Yes. No, that makes sense.
Okay, so that way it exists, and it's this thing. It's the funky arrow. So you can say execute this action, take the result, put it into this function to produce another action, and that's the final action that we end up with.
Okay. Yep. That makes sense.
Okay, still with me so far?
Yeah.
Okay, now this gets really tedious because let's say I now want to print the same thing 2 times after getting the line. What I want to do is like also string along the result into here, if that makes sense. So what I want to do is
Okay.
actually make a lambda here. Let's call it S, like so.
Okay.
Do you understand that this would print it twice?
Yes.
Files, right? Yeah, it does. Now this gets messy real quickly. So what instead we've noticed is that there is this pattern where if you rewrite this a bit, almost all of your code starts to look like this. Right?
Mm-hmm.
Where sometimes you need to do something, we'll give the result a name, and then we do some other things. And if we need the result, then we'll give it a name. If we don't need the result, and then we'll use this arrow. And if we don't need the result, then we'll use this arrow. And this pattern is very easy to extend as well. So let's say I need another line afterwards. This works, right?
Sure.
And then I want to maybe print it twice, and then I want to print the original thing again. Right? And this, if you squint a bit and just in your mind ignore the arrows here, right? This starts to look a bit like programming, doesn't it?
Yeah, with dues.
And now if I remove these as well, and I kind of don't put them in these weird lines, suddenly this starts to make sense,
Mm-hmm.
doesn't it? And if I keep doing this and I add a do in front and I put a left arrow here and a left arrow here,
Mm-hmm.
then we have what's called do notation sugaring.
Okay. So that's where all that stuff is kind of happening behind the scenes, so we don't have to write really
Exactly. So
unreadable
this is
code.
happening at the syntax level. So at the syntax level, this gets transformed into this.
That makes sense.
Does that make sense so far?
Yep.
Okay, so then I'll give you a nice riddle. Let's comment this out for a moment. If I say A is an int, A is do let 5 in 5. Let's say like this. Let x equals 5. X. What does this do?
Let x equal 5x. That's just
Really
saying x is equal to 5.
Right, but what in particular, what would this desugar to? And what it desugars to, oh, I forgot to explain the let. Yeah, the let is the, hold on, I need to back up a bit. I have to explain that as well.
That's okay.
If you have let bindings in here, let's say you want to name something else, you can say let x equals 5 in, like so, and you can put let bindings in between.
Mm-hmm.
Right, and this way you can give names to other things. And when you then do this, the do notation sugar, so first we ignore that those arrows are there. Then we get rid of the parentheses. And then we remove the int. And we put everything next to each other. And we turn the arrows around. And we put do in front. And it looks like code.
Okay. Yep, I'm following you.
Do you see the difference between the left arrow and the let binding here?
Yeah. I mean, x is a value with no IO. It's pure. So you
Right,
need the
but
left
S is
arrow as
also
part
a
of.
value with S is also a value with no IO, it's pure. The big difference is not the value itself, but how you got it. This S came from this desugaring. And it needs to come from
Okay.
there in order to chain those actions together, because S doesn't exist at the time of compiling.
Right. Sure.
Okay. So the difference between this s and this x is not its type, because s might be an int and x might also be an int, but rather how it got there. S is the name we gave to the result that this getLine action will produce. And x,
And by an action, we mean just like calling a function, or is there
so an action
something
is
more specific?
an action is the effect of changing the world.
Okay, so it does have to do with IO in that sense. Like we're okay, that makes sense.
In the current context, yes, but not necessarily.
Okay.
We'll get to the non-Ionic parts of this later.
Yep. Okay.
Okay, so you understand the difference between let and left arrow. So you
Yes.
couldn't say s equals getLine. I mean, you can, but then s is the action, not the result.
Okay. Yeah. So you're saying that you're saying there that S is actually just equivalent to getLine. It's just like renaming it as a
Exactly.
function
Right.
instead of the result of running that function.
And okay, and now I can show you how stupid this desugaring is. And by stupid, I mean it literally. Like you can say do let y equals 5 y. So what this desugars to is this, which can then be constant
Okay.
folded to 5.
Sure.
Right? So it's really just that stupid. But if now you say y drawn from getLine, for example, and let's say we return that, there's what you're saying here is we're gonna do an IO action, getLine, and then bind the result to a name y and return that y. And this will not compile, no surprise, because this arrow and then using results in an IO action, and this thing is not an IO action.
Okay. Yeah. And it's because you're returning. Well, I guess I get a little confused there because part of me says, well, you're returning y, and y is an int, but
Yeah,
it's
but
not.
wait, I have to explain. Return, put something into an action. Return says do nothing and return this result. But it's important, the doing nothing is a doing.
So is that like unwrapping the IO? Oh wait, no, you're returning the IO.
Yeah, there's no such thing as unwrapping IO. That's the whole point.
Mm-hmm.
But return put something into this IO context
Mm.
so that you can then use it in something like and then using. This is called bind, by the way.
Mm-hmm.
So
Okay.
if I say y drawn from getLine return y, and this desugars to this bind operator, this bind operator has a return type IO action, in fact, and it will be more general like this. And this thing is not an IO action, so I'll get a type error. Make sense?
Yep. Yeah, I start thinking about how to not get the type error, but yeah, yes.
Yeah, don't worry about not getting the type errors are good. They mean that you've successfully avoided doing something stupid.
Mm-hmm.
It's really not a great piece of communication to call it an error, in my opinion. In fact, in my view, these errors, quote unquote, that you get from compilers should be called messages and they should be green, not red, because you've successfully avoided doing something stupid instead of failed to achieve something.
Mm-hmm. I get
Okay?
that. That makes sense.
Now, so it makes sense that this does not work. Right. So if I say x is a value, what I'm claiming is x is pure, no actions happen when x is in existence,
Right. I
let's say.
guess that makes more sense to me. There is that you're trying to tell the compiler that X is pure and it's an int, and actually there's some IO in there, and it's not quite just an int.
Yes, indeed. There is no, like, if x is an int, that means I know, like, no actions need to happen to produce it. It is already an int. If x is an IO of int, that means the int doesn't exist yet. I'm only producing or only describing a recipe for achieving one.
Okay.
And then this will compile. If I
Fix the int char thing. Yeah.
yeah,
Strings.
right, yeah, there should be a read line. Okay. Okay, so now you understand how the desugaring works. You understand the difference between let and left arrow, and you understand why pure values cannot use actions. So far, so good, right? Okay. Now let's have a look at another problem. Here you see x equals 5. What is x?
5. An int.
Sorry, yes. You gave two excellent answers, and the question was too open. What type is x?
What type?
Yeah.
I guess that's a trick question. I want to say
Exactly.
int, but is it IO of int?
Well, GHC seems to think it's an integer, right? But if I say, nah, it's a double, then it'll go, oh, yeah, my bad, it was a double. Right? So somehow GHC decides, oh, this must be an integer instead of a double, unless I say, no, it's actually a double. And if I now say print x, it'll figure out it was an integer by the time it needs to print it, because it needs to know that it's an integer in order to print it. Right? So there's some mechanism, we call this the defaulting mechanism, that decides when you don't know what the type is, this is the default that we're going to go with.
Sure. Okay. Yep.
And this is turned on in GHCI, and it is turned off in GHC. Because if the compiler cannot figure out which type you meant exactly, it is a really good idea that it doesn't guess. Right? So indeed, if I now say GHC file.hs, that should not have worked. Yeah, there we are. It says defaulting the type variable. So I was wrong. It does do defaulting in GHC, but not if you turn on all warnings. So it says warning. I'm guessing, right?
Yeah,
Okay.
I was going to ask about that because I've seen it guess when I haven't put the exact type. Sometimes when it's a little ambiguous, and then if I define it, it's like oh okay, you really meant that, and then I'll actually sometimes get completely different errors, and that's one of the fun ways as an intermediate or noob Haskeller, you kind of run in circles.
Right. So here's one of the issues that you deal with. This and then using doesn't just work for IO. It doesn't even just even string is not accurate. It can do this any action that produces a result, take the result, produce a new result. Right? And it doesn't just only. So this makes sense so far, doesn't it? And it doesn't just do that for IO. It can do that for anything of a certain caliber, let's say. There is something special about the things for which this is possible. And this, what I'm calling special, is that we call it a monad.
Okay.
Dum dum dum.
Sneaky.
Exactly. So, and because this works for any monad, if I say let me remove this for a moment so it doesn't get in the way. Let x equals 5. Let x be an int. X equals 2. Let's say pure 5. Something like this. it'll say couldn't match type int with actual type MB. Right? So it's saying.
Well, that's looking familiar.
Yeah, exactly. This should be a monad, but it's not a monad, right? Like this should be of the kind star to star, namely it should be like two pieces instead of one piece, right?
Mm-hmm.
So if I now say x drawn from 5, pure y, I'll get the same error. I'm trying to figure out. So the problem is as follows. If GHC doesn't know which monad you're talking about, and you're talking about pure code here, and knowing that list is also a monad, but you don't need to know how it works, sometimes it'll guess that the monad you're talking about is the list. And then you'll see very fucked up elements.
Oh, bastards.
And then you see a very fucked up error message that says like, this is a list of int instead of an int. And then you go like, why are you bringing up lists? This doesn't make sense. That's why. So for example, I think if I do pure 5, how does it work? Yeah, I can't seem to reproduce the error, but you seem to have reproduced it in your own work, right?
Oh, yeah.
Yeah, no, I can't figure it out. Can't figure out how
Yeah,
to
because
reproduce.
I started with a function that was pure in the sense that it returns just the data type. And then I started to go down this path of taking what is basically a string, which is a list of ints, comma separated string of ints, and parsing that down to a list of ints. And so I needed a new function to do that parsing. And that starts to get into IO, and it could potentially fail and throw, it's in either string int. So I might have an error. So I ended up having two functions to parse that down to a list of, either string ints, and then get that down to a list of ints and fail gracefully if there's an error in there, and print that error. So my original pure function now is calling those two other functions, which are, have some IO embedded in there for the parsing, I guess. And that's where I started. That's where I got just like, it just went sideways.
Right.
I was lost in the
Yep,
main.
exactly. So we can have a look at your error in particular in a bit. Is there anything else you want to know about the general issues here before we do that?
Yeah. So with this X here, I mean, how do you tell it that it's not a monad, a list monad or something? Like it's was certain.
Well, you don't use anything involving monad constraints. So for example, you can't use do notation if you're not in a context. So if it's a pure value, don't use do. And if it's a pure value, you always need an in for the let.
Mm-hmm. Okay.
That's the big trick. So I'm going to write that down. If you want to name a value, use let. If you want to name a result, use left arrow. If you want a pure value, use let in and never do. Those are the tricks. And those are the tricks that you can use without understanding any of this. Okay?
Yep. Okay. Yep.
Okay, and then the last little piece of annoying bit is that pure is the same as return, but pure is preferred these days. That's all.
Oh, that's new.
Well,
So I shouldn't be using return. Use pure instead.
Yeah, use pure. So pure correctly says that this is a pure value, but we now want to turn it into an action.
Hmm.
Okay. So these three tricks are really the crux of the matter. I think we should stop the recording there.
Sure. See, do I hit this button? Where's the button? Stop recording.